Good day. I am Joseph Del Rosario, studying MS Chemistry in Cuba. And now I'm presenting my final output for CM211P for the oral presentation. My presentation is titled, my lab works is entitled Migration of Antimony in Polymeric Toys using AES or Energy Dispersive X-ray spectrometer or EDX based on a PNSBHT ISO 8124 3 2008 Safety of Toys, Part 3, also called as the migration of certain elements. So this study, I solely based on this procedure. Ito yung gamit namin in our office, the official method, uh, PNSBHDT. So I analyze antimony. So far, we have validated four metals in analysis of toys, especially in polymeric. We have validated lead, cadmium, arsenic, and mercury, but antimony, this is yet to be done. We have planned this way back 2018, but unfortunately the project didn't push through. So I chose this because hindi pa to validated sa office namin. And this might give uh, an insight or idea before we push this in our lab to get verified or validated. So going on, the purpose of this study is to describe the chemical analysis for migration of certain elements for polymeric and similar materials, including laminates, whether textile, reinforced or not, but excluding other textiles from parts of toys except materials not accessible in accordance to this procedure, our official procedure, Philippine National Standard BHDT ISO 8124-32 series of 2008. Also, this procedure specifies maximum levels and analysis for migration of the elements antimony. This is the elements covered by this procedure, but I'm now focusing on antimony only for this study. So it covers also arsenic, barium, cadmium, chromium, lead, mercury, selenium from for toy materials and from parts of toys except materials not accessible. So citing from from the PNS is very essential for the computation. For uh, for antimony, we use this specification 60 at more than 60 ppm, and for the computation, we will use 60% for the analytical correction. Later, I will show you how this is done, how this is used. The the computation for the computation, the 60% analytical correction. So for the specification, it should be not more than 60 ppm for this material, any toy material given in clause one of the procedure, except modeling clay and finger paint. Ito sa modeling clay, 60 rin pala siya. Yeah, 60 rin. Sa ibang metals kasi magkakaiba. Like this in cadmium, 75 sa polymeric, and sa modeling clay is 50. So next slide. I'm I will introduce the main instrument that I used in this experiment, the EDX, Energy Dispersive X-ray Spectroscopy or EDS. EDX, also abbreviated as EDX or XEDS, is an analytical technique that enables the chemical characterization or elemental analysis of materials. A sample excited by uh, energy source, such as an electron beam of an electron microscope, dissipates some of the absorbed energy by ejecting a core shell electron. Also, EDX does the position of the peaks in the spectrum, identifies the element, whereas the intensity of the signal corresponds to the concentration of the element. for the EDX, materials. This is the covered materials to be analyzed by EDX for the analysis. Sensitive to low concentration, the advantages of EDX. Minimum detection limits below 0.1% in the best cases. Affords high degree of relative precision, typically 2 to 4%, non-destructive in most situations, usually requires minimal sample preparation effort and time. Delivers complete analysis of complex samples quickly, often in under a minute. So this is the actual picture that I use in Shimadzu office in BGC. This is when we open it. This part, this is where we place the sample uh, here in this part, and then bablock siya ng ano ko, ng video ko. This is the sample holder with the film. Tinutwist lang siya, and then you pour half fill of the sample holder, cover with film, and then you will put it inside. May slot siya rito. I know meron pa to ibang accessories. You can place multiple number of cover of sample holder, but here we just use one kasi konti lang na may inanalyze ko. So this is the calibrating chip. According to the Shimadzu engineer, ang covered ng EDX is sodium to uranium. So, nasa in the middle of ang antimony. Pero in their calibration, using this, hindi naka-identify si itemize ang antimony. So, their explanation is lighter kasi si antimony. Pero it doesn't mean na hindi siya hindi siya naka-itemize in calibration. They can still analyze the amount of antimony. Kumbaga nasa range pa rin siya, mahahagip pa rin siya. Hindi na siya naka-itemize. Pero we can buy certain chip of this na if you want to see antimony itself, may ganong variant ng calibration chip. Gagano siya 2 centimeters wide lang siya. And then, this is how you place it. And in the sample holder, and meron siyang accessory, parang carousel, to place the multiple number of sample holders in one reading. So hindi ka na bukas-bukas, hindi ka na papalit-palit pa ng cuvette or ng sample holder. And then this is what we need in this analysis for the extraction, for preparation of sample, the following. Also, now in sample preparation, we remove the coating of the laboratory sample by scraping at room temperature, comminute at a temperature not exceeding ambient. So collect enough coating to obtain test portion, preferably not less than 100 milligram, which will pass through the metal sieve of aperture 0.5 millimeters. So next, the extraction procedure, using the appropriate size. Although this is, you can see this in my technical paper. Using appropriate size container, we cover mix the test portion prepared in procedure 1.2 with 50 times its mass with an aqueous HCl solution. We use 0.07 molar HCl for the extraction. Here I use 1 gram of the sample scrape sample toys, and then 50 times I weighed in the analytical balance 50 grams of 0.07 molar hydrochloric acid. So aqueous lang siya, hindi siya ganun toxic. Mababa na lang siya. Of course, with proper PPEs before performing the analysis. So 50 times, around 50 grams din siya when you tear the bottle with the scrape sample, 1 gram of sample. Then shake for 1 minute manually. You can shake it anywhere, any manner you want to shake it manually. And then check the acidity of the mixture. We have to get the pH. If the pH is greater than 1.5, add dropwise while shaking the mixture of aqueous 2 molar HCl until pH is between 1.0 or 1.5. Pero usually I get in between already because HCl is acidic. Uh, Pero pag di mo na-reach kagad, yeah, you may adjust using 2 molar HCl. So protect from the mixture from light, agitate the mixture continuously at 37 degrees plus for water bath, a shaking water bath. And then filter and then filter the extract after agitating in the water bath. So for the elemental analysis, for the extract, we eat the example holder that I showed in the previous slide, half fill only, and then read the EDX as prescribed by the applications engineer or service engineer. As a disclaimer, in operating the EDX, puro taga Shimatsu yung nag-operate. So wala kasi ako experience in operating EDX. I just watch them. I just ask them what to do, what do I expect from this from this solution, what consideration should I expect, and then they're the one using the operating the instrument, the EDX. Kasi wala taga experience na tao, masira ko lang. So next, the procedure. This is the sample. I just got the yellow part. So para uniform. This is the toy truck that I purchased. This is the mill, plastic mill that I use. So I cut first the sample into pieces so it will fit the mill. And then this is the mill and may bleach, yeah. And then this is the uh, scrape sample, grinded sample. And then this is the finished product. This is the one we will weigh 1 gram with the with the 0.07 molar HCl. So ganito siya pag pinagtyagaan mo siyang mill. Uh, Ganito siya ka-mill. And then for the results, the analysis dates are July 8th, July 17th, and August 3. So, baga, on July 8th, I did in the previous slide, I did the sample preparation at Mapua Laboratory. That was Saturday. So, I passed immediately the report before the deadline. But unfortunately, in the next 2 weeks, didn't make it on time because nakiusap lang ako sa Shimatsu. It depends how what schedule they will give me. So usually yung deadline na Monday or Sunday by Dr. Martin, hindi ko na-meet. So I apologize for that. I also explained to Ma'am Marilyn my predicament. So uh, when I analyzed in July 17, I immediately sent through email my my progress report, and August 3, my third analysis. I will explain later. First, when on August, I will show. On August, this is the calibration of the instrument. On July 17, I just prepared uh, sample and spike in ppb levels. So we had a miscommunication with the service engineer. Yung pala ang EDX can only read ppm levels, hindi ppb. So parang in-incorporate ko siya since ang gamit ang instrument for Timony is HVG. So it only reads at ppb level, parts per billion. So si EDX ay hindi niya mariread yung mababa. So yung pala, when I brought the sample on July 17, ang nasalang ko lang is yung unknown sample. So expectedly, the antimony there is not detected. So when the samples at the working standards that I brought together with the spike solutions, hindi siya ma-read kasi PPP level siya. So I made another appointment That was on July 3, kaya thank goodness, pinagbigyan nila ako. Kasi yung July 26 to 29 na that was the Chem Congress. So they brought the EDX in Bacolod for the demo. So hindi ako nakagamit that week. Fortunately, they gave me the schedule August 3 before this final presentation. So this is the calibration of instrument. I use from 1 ppm to 50 ppm. So the accuracy is 1.95. This is the accuracy. 1.95. Sabi ng taga Shimatsu, this is an ideal calibration linearity. For this is the calibration. So na-read na siya this time. Ito yung August 3. Na-read na siya. Kasi ppm levels is tinaasan ko na. So the result, the calibration of instrument, this is the continuation of the calibration. This is the amount of the calculated value, the deviation from itself. So, ayun nga, when standard value, 1 ppm, nag-negative siya rito lang. Pero, nagbawas dito kasi ng standard kasi malayo. Outlier is 3 ppm. So, the rest, 10 ppm, lapit naman siya, 9.7. From this calibration, dapat mas mataas talaga ang calibration standards, more than at least 5 to, we can try up to 100. It depends na lang on the interval that we will use for the calibration of instrument. So malapit lang siya, 40 ppm, na rin niya is 41.86. So next slide, the result. Upon analyzing the unknown sample, trial 1 not detected expectedly. Good thing the toy is not contaminated with antimony. So this is the sample weight, 1.048 grams. The sample, the diluent, 0.07 molar. HCl, 50.048 grams. So here, formula is what we use in our office. This formula, actual concentration times the dilution factor times the correction factor times the 1 minus the analytical correction. So kanina analytical correction is 60%. So it will be 1 minus 0.6 and divided by the sample weight. So it's a dilution factor, diluent, that will be 50. This one. We will use this weight. So here, this is the result, PDF form given to me by the engineer of Shimatsu. As you can see here, wala siyang antimony. So ni-read niya on easy mode, easy group, yeah. Here, as you can see here, hindi detect daw ni EDX up to 100% of all the possible elements that it can analyze, it can detect within your sample. So actually in this sample then, they can analyze also the powder form that I showed. Pero kasi, I said in our routine, we analyze the extract, the liquid extract. So it will be infutile or value wala lang if kung may ma-read man sa powder form. So hindi kasi yun yung sample prep namin. So here, wala siya antimony, so we concluded na it is not detected in trial 1. So in trial 2, same, the result is also not detected, the following weight of sample and the diluent, same formula, and then this is the reading, no reading of antimony again, collecting up to 100% of each element present. Kung ano yung present na i-detect ni EDX. For the result again, this is now the spike. So 10 ml of 1000 ppm standard to the sample preparation. So as is lang, sample prep lang, 1 gram of sample, 50 grams of the diluent, 0.07 molar HCl. The expected reading in EDX is 200 ppm. So tinaasan ko na talaga kasi para also in this reading nga pala, as for information din. Parang this is also sort of a learning for the Shimadzu staff kasi this is their first time to read this. Kumbaga, study rin sa kanila ito is how, kung gaano kataas yung kaya i-read ng kanilang instrument. Kasi sarili ko itong sample prep, hindi yung usual na sample prep for the tsaka liquid yung gamit ko. Usually ito sa solid na kanilang ginagawa sample prep. So my expected reading is 200 ppm dapat. So spike 1, this is the weight, 1.0207 grams. The diluent is 50.00887 grams. So this is the reading. I recovered 140.6 ppm. So mababa sa 200 ppm. So when I calculated it for the recovery, this is the recovery. For the theoretical computation, I pipetted 10 ml here, and the weight times 1000 ppm, the concentration of where I got the standard from 1000 ppm, and then 1.06 this is the correction factor. Analytical correction, since kanina I showed you 60%, so we will make it 0.6 of the correction factor for antimony, 1.06 over the weight of the sample. So this is the theoretical theoretical concentration 3,918.88 for the actual sorry for the sa barangay antimony actual concentration 140.6 ppm using this weight again, the dilution factor 1.06 1.06 and then divided by the weight of sample. So here the actual antimony is 2,775.45. So getting the recovery actual over theoretical, I got 70% of the recovery. Next, for the trial 2, again same spiking method. This is the weight, this is diluent, and then I got 104 only instead of the expected 200 ppm. Then next for the computation, again following the previous computation here, this is a theoretical. It varies. The theoretical concentration depends on the sample weight. So nag-iiba-iba kanina. So for the theoretical weight, we have 3,714.71 ppm, and for the actual antimony content concentration 104.6 times 50.0406 times 1 minus 0.6 divided by the weight of sample. So this is the actual concentration here. So around we have 52.34. So we have a poor recovery. If you will get the average, kanina 70, we will just get 60%. And nakalimutan ko yung rito, include na yung average. So usually when we get the recovery criteria, it should be, I think, 80 to 120%. So below yung aking nakuha spike recovery. From the conclusion, poor recovery was obtained. Ito nga po, because the spike sample, I used expired antimony, yun lang kasi available namin. Hindi pa kami nakaka-purchase. Expiry niya is 2019. Pero pansin naman, di ba kanina sa calibration, they can read pa rin the working standard. Kaso, maybe for the matrix effect, the sample, it absorbs some of the antimony when I spike it, so mababa yung recovery. So, good thing, antimony is not detected in toy sample. But EDX instrumentation, or as I said, all the Shimadzu technicians and application staff operate in the unit, since I really have no experience in using the said instrument. As recommendation, each VG is probably better or ideal to use to be used and, in analyzing antimony like mercury and arsenic. And so also you should use non-expired AAS. AAS standard must be used for the ideal result. So thank you for listening. This is my presentation for the week 11 of instrumental methods under Dr. Marilyn Martin. Also, I would like to thank I hope marinig nila to on YouTube. The staff of Shimadzu, Sir Von Chavez, Engineer Arvin Mercado, the applications chemist, Sir Donald, I forgot his surname, and all the other Shimadzu staff who assisted me in operating the instrument and giving me schedule, letting me their time, giving me their time to assist me in this study, in my master's degree study. So thank you sa inyo lahat, and thank you for listening, all the people who collaborated with me in this study, and also FDA and DOH. Thank you very much. Good day.